This ShowMe is about evaluating expressions. The first thing we need to do is understand exactly what an expression is. An expression is a mathematical phrase. It's important that we use the word phrase. The idea comes from language. A lot of what we work with in mathematics involves mathematical sentences. Sentences have subjects and predicates in language. In a sense, they do in mathematics as well. That subject, in English, would be a noun or even a clause or phrase. In mathematics, that subject is a phrase. The phrase could consist of a single number, or, as it does more often, a combination of variables, numerals, and symbols for operations. That's the kind of expression we're talking about here. The other word we have to understand is evaluate. When we evaluate something, we attach a value to it. Now, in attaching a value to something, it's not an arbitrary thing. We don't simply say, that's worthless. We don't simply say, that's 5. We have rules, some of which we've already talked about in other ShowMe, such as the order of operations, for helping us to determine what the value of an expression is. Hopefully the examples I'm about to show you will help you understand more about both expressions and how to evaluate them. In this problem, we're going to evaluate 4y minus 15. 4y minus 15 is our expression. We're going to evaluate it in the situation where y happens to be equal to 9. To evaluate, then, the first step would be to make a substitution. We can substitute one number for another whenever we know that they are equal to each other. We know that y is equal to 9. So, from now on, wherever we see a y, we can replace it with a 9. Let's do that here. Instead of having 4 times y, we have 4 times 9, and then minus 15. Now we're back into a situation where we have to use the order of operations. Multiplication should be done before subtraction. 4 times 9 is 36. If you notice, we just made another substitution, because we know that 36 is equal to 4 times 9. We conclude with yet another substitution. 36 minus 15 we know is equal to 21. Now we have evaluated the expression. When y equals 9, 4y minus 15 is 21. Notice we didn't just pick a number and say it was equal to 4y minus 15. In evaluating it, we followed rules that we had established before the problem was ever assigned. The same game is afoot here. Our expression is 63 minus 5x. We know that x is 7, so we can replace it. We can make a substitution. 63 minus 5 times 7. Multiplication should be done before subtraction. 5 times 7 is 35. And then 63 minus 35 is 28. The value of 63 minus 5x is 28 when x is 7. Despite the greater level of complexity in this particular expression, the procedure remains exactly the same. First we write our expression as it was given, and then we rewrite it, making the appropriate substitutions. And now the order of operations guides us to the finish line. We have 8 plus 3 inside grouping symbols must be done first. 8 plus 3 is 11. Now we should multiply before we add. 4 times 11 is 44. And then 44 plus 1 is 45. Here we take another step into greater complexity, and yet the rules remain the same. Duplicate the expression, and then rewrite the expression, replacing each variable with the appropriate value. A is to be replaced with 2. And B is to be replaced with 5. And finally, C is to be replaced with 10. We have both multiplication and division to do. We should work from left to right. 3 times 2 is 6, and then 6 times 5 is 30. 10 divided by 2 is 5, and then 30 plus 5 is 35. Despite the large number of variables involved here, the procedure is largely the same, and once the substitutions are made, the problem is no more difficult than the others that we've done. The grouping symbols rear their ugly heads here again, but as before, the procedure remains remarkably simple and consistent, which is a hallmark, by the way, of good mathematics. We love for things to be simpler and consistent so that it's easy to explain and understand what to do in different situations, and so that we always have a consistent place to aim for in trying to simplify problems and turn them into problems we already know how to solve. G is replaced with 8. H is replaced with 7. 8 plus 7 must be done first because it's inside the parentheses. Normally we would do multiplication first, but in this situation we shouldn't. 8 plus 7 is 15, and 6 times 15 is 90. Again, with the multivariable stuff, it's the same process. 2xy minus z becomes 2 times 4 times 3 minus 1. We should do multiplication first. 2 times 4 is 8, times 3 is 24. 24 minus 1 is 23. Finally, a brief but important reminder about division bars. The procedure hasn't changed for the division bar, but the order of operations situation with the division bar remains something of an anomaly. Division bars are grouping symbols. The other grouping symbols always tell us what to do first. The division bar effectively seems to be telling us what to do last. Still, we'll replace R with 13. Still, we'll replace S with 11, as before. And now to decide what to do first, well, we should add first. Remember that grouping symbols usually tell us what to do first, and the division bar is the only obvious thing here. What isn't obvious but must be understood is that effectively, division bar also creates 2 sets of parentheses. And that is why whatever has to be done in the numerator or in the denominator must happen first. Now in this case, there's nothing to be done in the denominator, but there's a little bit of business upstairs. 13 plus 11 is 24, and then to finish it off, 24 divided by 2 is 12. Now this may seem very easy, and it's something that a lot of people take for granted, but it is a crucial skill. A lot of work done in the workplace involves plugging numbers into formulas. It's important to understand what the formulas mean. That training will be done at your job or in more advanced courses or in more specific courses. Here in algebra class, what you must be learning is the proper way to substitute numbers into these formulas, and then of course you've got to practice your order of operations skills over and over again to make them automatic. I would expect you'll have a lot of exercises about this topic. It is crucial. It's also especially important when it comes time to work with computer spreadsheets or database programs, where creating these formulas is an important part of making the program more efficient and effective in processing information.